This is the third video in the series. In this video, I'll explain about linear combination of vectors. Let me take up a set S is equal to V1, V2, so on up to Vn, containing n vectors of a vector space V over the field F. Then, linear combination of vectors is any vector of the form alpha 1 V1 plus alpha 2 V2 plus so on up to alpha n into Vn, where alpha is taken from the field, is called as linear combination of the vectors of S. So, formally, linear combination is nothing but it is scaling the vectors and adding those vectors. There are different possibilities to scale a vector. Either you can increase the length or you can decrease the length, increasing in the opposite direction or increasing in the same direction, squeezing the vector, stretching the vector. This is called as scaling a vector, which I had explained in the previous videos. So, when you do that, there are different possibilities which will add up to a new vector. So that is called its linear combination. Let us take the set S is equal to having two vectors 1, 2 and minus 1, 0. So linear combination is represented as alpha into 1, 2 plus beta into minus 1, 0. So when you keep on changing the values of alpha and beta, you will get different possible vectors which are called as linear combination of these vectors. See, for example, let me take alpha is equal to 1 and beta is equal to 2. So 1, 2, this vector is represented here 1, 2 and minus 1, 0, that is here minus 1, 0. So 1 into 1, 0, 2 means I am not scaling it. 1 into anything, it remains same. So neither stretching nor squeezing. So 2 into minus 1, 0, I am increasing the length by 2 units. Already it is of 1 unit, 1 more unit I am doing. So minus 2, 0, it goes to the point minus 2, 0. Let us scale this vector. Okay, so it comes to be minus 2, 0. Now add these two new vectors. One is minus 2, 0, one is 1, 2 using the parallelogram law of addition. So this goes to minus 1, 2. The same thing is obtained here. So this is the linear minus 1, 2 is obtained by the linear combination, one of the linear combination of these vectors 1, 2 and minus 1, 0. Similarly, take alpha equal to 2 and beta equal to minus 1. One more linear combination of these two vectors you will get, that is 3, 4. That is 1, 2. 1, 2 is stretched. Now I am increasing the length. Increase it till the length. It becomes 2, 4. It goes to the new vector 2, 4. Another is minus 1 into minus 1, 0. Minus 1, 0 is here. Okay, it's a length now. Multiply it by minus 1 means change the direction. Increase the length but change the direction. So this goes to here 1, 0. So now these two vectors will get added up to give you the vector 3, 4. So that goes like this. 3 and 4 come somewhere over here. So that is the resultant 3, 4. So this is one vector which is obtained by combining these two vectors. That's why they are called as linear combinations of the vector. Not these two vectors. There are infinite vectors like this. You can go on changing the value of alpha and beta. So you will get different possible vectors. So that is called as a linear combination of the given vectors. So it is scaling the vectors and adding the vectors. There are different possibilities when you change the scalars. Okay. So that gives you different vectors. That's called as linear combination of given vectors. Thank you for watching.